Hey, 8th grade math, Catlin here with your cool down help. I'm going to do two lessons today because we actually skipped lesson 13. I feel like we covered it well enough on Monday. So lesson 13 was still talking about explaining how things are congruent, why two shapes are congruent to each other. So are these two congruent? If they are, yes or no, and then give your explanation. So is figure A congruent to B? Well, if you used your patty paper, you'd notice that this one is not the same. They actually have the same height. They're both 2 units tall. So it's not a matter of how tall they are. It was more that their width was different. So half, 2, and another half makes 3 units in width, whereas this one is a nice solid 4 all the way across the board. So part of your reasoning could be, obviously you're going to say that they're not congruent, and then you need an explanation. Now, we have a blanket explanation for anything that's not congruent. And when you use your patty paper, you're proving it, because this figure over here on the left cannot be transformed rigidly to land on figure B on the right. That would be plenty of an explanation. You could also say that the length of figure B is not equivalent to the length of figure A. That would be another explanation that would work, because all sides and lengths and measurements and angles have to be the same for two shapes to be congruent. So you can kind of put that into your own words. I'll grade that on Friday and deem whether that's a good enough explanation or not. But let's get into what we talked about in class today, which was your alternate interior angles. So this is a new thing. And honestly, you really don't need to know about that to answer this question. You could use your information about vertical angles, and your information about supplementary angles would be enough. But since that is the key of today, I will make sure I cover it in the cool down. So if it comes up later, those that are at home quarantine or whatever can figure it out. We've got two parallel lines. That's important. If they're not parallel, then we can't have alternate interior. They're cut by this transversal that goes all the way across like this. One angle measure is shown, so we have the 54. So the first thing that I do whenever I have something like this is I want to go ahead and knock out my vertical angle that's always across when I have intersecting lines. So I know that B is equal to 54 degrees because these two are vertical to each other. They're like reflections of each other across this imaginary axis that I'm highlighting right here. I can flip it across that and it would land on it. It's identical. But what alternate interior means is this, and I'll try to draw it for those that might have missed it. You've got the interior of your parallel lines, which is what I'm highlighting here in yellow. It's on the inside of the parallel lines. And then you have 54, which is on the right side of the transversal. This is your transversal here. Okay, so it's on the right side of it. And the alternate side of right is on the left. And so, since this angle D is alternate interior to angle B, they are equivalent to each other. B and D are the same. So we could say that D is also equal to 54 because they are alternate sides of the transversal and they're interior of the parallel lines. So that's why we can get that one being 54 degrees. So I'm going to write that down. This one's 54 degrees, which tells me that this is 54 degrees because it's vertical. So we got all the 54s knocked out. You also could have done that with a translation across there from that vertex to that vertex. You know that the corresponding angles are equivalent. We saw that in our lesson. But let's do the other set, because the other set has to be done by using supplementary relationships. So let's talk about our supplementary angle relationship, which can be used to find out angle A here. If you look at angle A and the 54 degree angle B there, you'll notice that they fall on a straight line that is 180 degrees. Thus, A plus 54 must equal 180. And so to find the missing part of this equation, of this sum, we can take the 180 and 54 and subtract it. So A will simply just be 180 minus 54, which if we count up, 6 gets us to 60, and then you need another 120, so this would be 126. And you can test that by adding those two together. 54 plus 126 is 180. So we're confident that this is 126 degrees. This is vertical of it. This is on the left of the transversal inside, and this is on the right. So these are alternate interior, G and AR, to make 126. And then vertical here, you can just knock them all out. So A turns out to be 126, which I had down there, sorry. B, we got C is 126 degrees. D is 54. E turns out to be 126 degrees. B, C, D, E, F is 54, which we had already labeled right here. And then G is 126 degrees. So that's all of the angles. They're either going to be 54 or 126. And they're like spitting perfect identical images of one another because of the parallel nature of the lines that the transversal is cutting. And that is what we learned today. And I hope that was helpful if you didn't get it out of the regular lesson. Adios, amigos.